Alright guys, welcome to my spatial inventory system. I'm really excited to share you this one. I'm gonna do a full complete course for this, and this is all free at its current state. So this means the whole spatial inventory system is done and has no bugs for now. So we can pick up, don't mind, those are all placeholders. So the meshes are just placeholders. We can always change inside the blueprint. This is pretty simple, but I can, for example, now pick up a herbal item. This is another herbal item. I have stack. So this is a max stack of 2. I can add another one. So now I have another one here in a new slot. Stacking it automatically always. And I can put this guy here if I want to. Or I can just get this one and rotate and put this like so. And I can put it here and rotate it here. And so I can do basically anything I want. And I can add a pistol. So let's see. And the pistol is being placed at the next possible empty grid. Okay. So then let me just rotate here again. And put this guy here. Okay. So yeah, if you're excited to build this one, feel free to follow along. We're going to start now, and it's going to be split into several lectures. And if you really like blueprints and gonna program a lot and you really want to dive deep into inventory logic, because this is more of an advanced tutorial, but even as a beginner you have the chance to follow along, because I'm gonna show you everything in detail how to build this one. So let's get into it. Alright, so let's start up the 5.8 project for this one. Just hit a launch. Let's do a new project, makes sense. And what you're going to do is the third person template, and then you can just create this project. All right, here we are. So what I'm going to do here, you don't really need to do that, but I'm just putting the viewport scalability down to low, just to make things a little more performant while we are working inside the blueprint. Let's create a folder first. So we call this one inventory. And here we're going to store all the structures and the data tables, blueprints, the actor component, all that stuff. So we start by creating a structure. So you can just simply search for structure. We call this one s_item shape. So we first want to define our item shape. When we open this one up, we need 2 variables. So you can click here, add a variable. So you're going to have 2. And the first one is going to be an so-called int point. This one here, just a simple int point. And we need a bool array. The first one we call dimensions. So this is basically the X and Y. So how we're going to place it from top left to right, and then he's counting down from top left down, like depending on how big our item is. And we need our occupied cells, and you can save this one. And that's basically it for the as item shape. Then we need another structure, so let's search again for structure, and we call this one s_item data. And inside here we need a little more. So first of all, we need the so-called item ID, which is a simple name. Then let's get another variable here, and we call this one display name. That one would be a simple text, another variable. That one would be our thumbnail later. So we don't need this for now. Just call this one icon and search for texture 2D. Here, the texture 2D object ref. Then another variable, we call this one basic shape. And this is what we already created. So inside here, inside the basic shape, just search for the S item shape. This is our structure we just created. So now we have a ref inside here also, which is essential later. Then another variable, which would be a bool. So just name this one B is stackable. And this is just a simple bool, another variable, and we call this one max stack size, which is, you might have guessed it, a simple integer. And we save this one. So now we have also, next to the shape the structure for our item data itself. So we can close this one. And we need a third structure. So let's get the third structure. We call this one as underscore inventory. I don't know. Let's call this one inventory item instance. Let's call this one. And let's open this one up, sorry. And the first variable, we call this one item ID. And that one would be a simple name. Another variable, which we're gonna call grid position, which is the endpoint. You might remember this one from our first structure. So we can calculate the X and Y direction inside our spatial inventory system. Then we want to rotate also later. So we're gonna prepare also the current rotation. I think we're only gonna rotate 90 degrees, so we only need 2 options, whether it's just rotated 90 degrees or not. So we don't need 4. 2 options is perfectly fine. So we can use a byte. You can just search for byte or just get this one here on top. And another variable, which would be then a GUID. So we call this one instance ID. And then you need to search for GUID, GUID, and save this one. Now finally, we can create our data table. So inside our data table, this is where we can store basically everything, any type of item you want to pick up later. So just search for the data table. And you're going to have this one down here, data table. And he's going to ask you what kind of structure we want. And we want to have the type as item data. This one here. Okay. And we call this one then DT for data table underscore items. So we can store all our items inside here. And here we can also define the size, the icon, the inventory thumbnail, whether it's stackable or not, and the max stack, if you want to stack it or not. And then we can define the amount. So let's add here the first item. And then you can see here on the top left, it's pretty hard to see, but this is pretty important, the row name. Just click here and then F2, because we want to call this one, for example, a green herb. So this is just you can call it this one potion or sword or pistol, shotgun, anything you like. This is just an example. And you can already imagine how big your item is going to be later. But if you want to change it, you can always go back here into the DT items, into this data table, and can change it also. So just for you guys to understand the green herb here, and now we created this one down here, okay? So now we can define the item ID, and we call this one green herb. And the display name, I call this one green herb. It's not that important, but this is just up to you. The inventory thumbnail you can add here, but we're gonna skip this one. We don't need that for now. The basic shape here, you can open this one, and inside the basic shape, you have dimensions. So for the dimensions, you can now define how much space you want to occupy. For the X dimension, you can see here, would be the size from left to right. So for example, if you have a rocket launcher, then the X dimension would be, for example, like 4 or 5 slots on the X axis. But then on vertical axis, up and down, the Y axis would only be 2, for example. 2 slots. So I hope you can understand what I'm trying to tell you. So for the green herb, I want to have 2 slots occupied, but it's just the 2 vertical slots basically. So for X, we only need 1. And for the vertical, so the Y, we need 2 slots occupied. And here you can define if you want to stack this item. So if you want to stack this item, you can say, yeah, I want to stack it. And the max stack size, you can set this one to, I don't know, how many you like. But in this case, I set this to 1 and I disable the is stackable because I really don't want to stack green herbs. If you have a different type of game, maybe a potion, mana potion, health potion, you might just want to have a stack of 20 or 50. Then you need to check is stackable, and then you can define how many you want to stack inside the same slot. Then let's save that. And just to give you another reference or another idea, you can also just add another item. Like I said, you can add all the items you want. press F2 here, and we call this one pistol, for example. And the item ID here, you can change this one. Let me also change this to pistol. We keep this one simple, and the description here, the display name, I should say pistol also. Dimensions, I would like to have a 4 and 4. So the pistol is basically now a perfect square of a 2 and 2 vertical and horizontally. And it's not stackable, but the max stack size is set to 1. And then we save that. And that's basically it for now. So here, feel free to add all the items you want. Now you understand what you need to set here. So the dimensions, you need to have a rough estimation on how big and what kind of shape your item is gonna be. You set this one here, X and Y. And that's basically it for the data table. So save this one and then close this. Sorry, before we close this one, so just save this one, okay? But I forgot one thing. When we go back to the green herb, we have also here the occupied cells. Sorry for that, I was just not seeing that here, just forgetting this. For the occupied cells, we need to define if our item has 2 slots in total being occupied. Okay, so vertical 1 and 2. We need to have 2 slots here. So the occupied cells, you need to click on the plus 2 times. And this one would be then yes occupied and yes occupied. 2 bools gonna be true. And then save this one. For the pistol, you need 4. Okay, so we have this item is a little bigger. We have 2 on the vertical and 2 on the horizontal, so perfect square, like I told you before. So we always need the same amount of cells, and you always need to enable them, okay? So this is pretty important. For example, if you have a rocket launcher and your rocket launcher is like vertical, let's say 4 or 6, so the X value, 6 cells, but the vertical is just 2 cells for the rocket launcher, so the Y would be 2, then you would have 8 occupied cells. So you're gonna need 8 of those index occupied cells, and they all need to be enabled, just for you to understand. Okay, and then you can just save this one. Now we're gonna build our actor component. So when you right click here and you go to Blueprint, we can find the Blueprint class. But when we open up the All Classes section, you can search for Actor Component. This is pretty cool because the Actor Component is giving you the ability to attach this always to your character. So you just get this Actor Component here and select. And we call this one a BEP underscore inventory component. Let's open this one up. And we can delete the event tick. We don't need that. We're gonna need the event begin play in a couple of seconds. But we need to get some variables first. So you have variables here. So click on the plus. And the first variable is being called grid width, which would be a integer. And then you can just click on that and Control D, because this one is being called the grid height. So our Y value. It's also an integer. Then click on the plus here. We need a different variable being called the grid cells. And this one is a GUID also, so we can connect this one later. But this one on the right hand side, set this one please to array. Then we need our structure. So search for the S inventory item instance. And we call this one placed items. Another variable, we call this one a cell GUID. And this is just a simple GUID. Just a simple object reference GUID. And compile and save. So we start with a simple for loop. So we want to always loop our empty grid, our empty inventory first. So for a loop, don't use the for each loop, we just need the simple for loop. And what we're going to need is the grid width, get this one. We need to get the grid height. All right. And what we're going to do here is we drag off of the grid width and hit the X on your numpad and get the multiply. And then you just multiply the width by the height. Drag off of the result here and get a simple subtract node. an operator subtract by -1, set this to -1. The reason why we need to do that is because we have an integer from first to last index. He's always counting from from 0. This is why we always need to subtract this by 1 to match the last index. So this goes into the last index. So this is the way you need to do. And then just save some space here. Just like that. And make this as close as possible here. Then we want to get the grid cells, drag off of here and get a simple add, just an array add, and connect this to the loop body, because we want to loop through the whole inventory we have, the whole grids we want to define. And for our GUID, we want to make sure that we just search for the make GUID. So let's just get an empty one. And we can fill this one here. So just connect this one also, like so. And save some space. Then here you can define your grid width and your grid height. So this means you can see here grid width multiplied by height. For example, if you want to have your inventory from left to right, so the size from left to right, you want to have maybe, let's say, 10 cells or 10 slots. And for the height, maybe you just want to have, I don't know, 5. Then set this one to 5. So you have 10 for the width and 5 for the height, okay? Your grid is cells. You can leave this empty because we have the grid cells here. And once we loop with our width and height and multiply this, this is going to get looped 50 times, depending on the value we have here. So 10 multiplied by height, 5, is going to be 50. He's counting from 0 and not from 1. This is the reason why we always need to subtract by 1, like I told you previously. Okay, so we can loop this inventory now. And on completed, we need a function. So once we add our item, we need to do stuff here, whether it's gonna fit or not. So let's start by creating the first function. So click on the plus here next to function. And we call this one can place, let me just type it like so, can place item add. Okay, inside this function, we need 4 inputs. Just get 4 inputs first. The first one would be the item ID. Sorry, I want to have this correct. Item ID. And that one would be a name. This needs to match with our data table. Because inside the data table, you can see here, inventory. And the row name is, it's a name variable. So this is the first input. The second input would be then the top left position for X and Y. But actually what we can do, we can delete one input here, sorry. We can actually do the top left position and use an int point. So we have the X and Y already inside. So we can break this one later. And the third input, we're gonna call this one ignore instance ID. And that one would be a GUID. We need an output. This is just a simple bool. And we call this one B for bool can place. That's it. We don't need this for now, the return. You can just alt click to disconnect this and put this here. We don't need this for now. What we need here, drag off of here, we need to get our data table. So get data table row. And what we want to choose is our data table items. So now you can see our first row name here is already green herb, but we need to connect our item ID to our row name. So later, when we have this function ready, we can always define what item we're going to store inside. So then he's going to do a check. So whether this item is being found or this item is not found. Not found, pretty simple. We just connect the not found to a return node, which is a false. So we cannot place. Because we didn't find it, we cannot place this item, okay? And here we need to do some things. So first of all, the out row, you can just drag off of here and then you can break the S item data. This is our structure inside our data table. You remember what we created here, right? So this is structure, the item data. And inside the item data, we have another structure, which is here, the basic shape, the item shape. So drag off of here and do the same step, break the item shape. And right click, you can straighten this connection if you want to. And from here, you can split the dimensions. Since this is an int point, an integer point, you can split this. So break int point, and you have x and y. And for the occupied cells, this is an array. You can drag off of here and you can count the length of this array here. And we want to make sure before we loop this one. So from the row found, just drag off of here and get another for loop, just a simple for loop. And then here we can put this into the last index. But as I already told you, for loop is always counting from 0 and not from 1. This means we need to subtract this one by 1. So it matches our count. Pretty simple. And put this into the last index. And let's give it some more space here. So once this is completed here, our for loop, we can get this return node. Just drag select or click on this and Control C and then Control V, and on completed, we can place. And let's put this one down here for now. Before we continue with our loop body here, so just in case if we find an item, we need to do some math first. We want to drag off of the x value here, our x output for our dimensions inside our item shape. And we need to prepare two basic calculations. The first one is a so-called modulo. And the modulo, you can just get this one by using the %. And then just alt click, or you can control and swap. This is pretty important. Or this needs to be inside the second input of our modulo. And then you always get the index of our loop and put this into the first input. Right click here and straight connection. Then we need another calculation here. So drag off of the x again. And this time it's going to be a simple divide. Just get this slash, so divide. Control and swap the connection. And you also get the index of our loop. And this is the first input. Then for our modulo, we need one more thing. We need to drag off of here and let's get a plus. So I just a simple add operator. And we also want to swap this one to the second input. And now what we need is we need to go all the way back here. And you can see we have the top left position. So right click here and you can split the pin. Since again, this is an int point, you have now x and y inside, so we can split this one. And you need to drag from the x here. So this is one thing you can do. Okay, or if you don't like that, you can also just right click and promote to a local variable if you want to. And then just rename this one to top left position x. But in my case, I just drag directly from the x output into the first input of my add. And then I will just double click here and put this up. But this is completely up to you. And then you can zoom out if you want to. Just drag those 2 points and press Q. So they are straight. And we need to do the same thing for the Y. So just copy the add node. Put the divide into the second one, into the second input. And now get the Y. And put this one into the first add calculation here. And then just make this a little more obvious, like so. And then just drag select and press Q to straighten it. And also you can here right click, straighten if you want to. Just to clean this one up a little bit, right click, straight connection. And here also straighten. Pretty cool. So now we can call this one here by like just drag select and press C. Call this one the absolute X. This is the absolute value of our X inside our inventory. And drag select here. And this one is the absolute Y. Now for the absolute X and for the absolute Y, we need two checks, like two bools for the absolute X and two more bools for the absolute Y. So what you can do here from the result of our add, we can get a is greater equal, and then also drag off of here again and we get less. Just get a less or inferior. And then we need to connect the width for our absolute X, makes sense. So we get the grid width, get this one, connect this to the second input and straighten this connection. So now we have two bools for our X, like basically from left to right, our occupied cells from left to right. Now for the vertical count, we need to do the same thing, just copy those two bools. So the first one goes into the first input and also here into the first input. So we always want to make sure that for absolute X and Y, it's always a positive value. This is basically the first check we have. And we also want to compare this to our height in this case for the absolute Y. This is now the height. So we always want to make sure that we stay inside the inventory. So if this one is greater than 50 for our cell size or outside of our grid, we can, of course, we cannot put this into our inventory. Then just right click and get an AND bool. Just type an AND bool, not bol, bool, sorry. And get 4 pins, 4 input pins here. And just follow the order here. Pretty simple. And you can drag select, press C, and this one is the B, so the bool in bounds. So this means we will always stay inside our inventory. When we want to move our item to a different place or going to rotate, we're going to make sure that this always stays inside our grid we just built. We have just built here. And then from here, drag off of here and get a branch. Just a simple branch. And this simple branch needs to be connected to our loop, so the loop body. So whether we're going to find the item or not. And then once we found the item, like I said, we check the inbounds. If this is false, just right click and get a return node. Just get a simple return node. Sorry, this was a little too fast. Return node. Just add return node. And leave it as it is. So we cannot place. So blank or disabled means no, we cannot place if it's false. If this is true, we need another function. Okay, so we need to prepare another function. So click on the plus here next to function. And we call this one get index from X, Y. So I am inside this function now. Just double click here, but you're gonna be teleported automatically. And what you need to do is just click here and get 2 inputs, 2 simple integer. We call this one X and Y. Sorry, click here. The output would then be another integer called index, because we just want to count our index here. So get some space. And this is pretty simple. You just get the grid width. And then drag off of here, get a multiply. Swap this input by holding Control, drag select, press Q to straighten this one, and you get the Y of the index. And the result we're gonna multiply with our width. You just drag off of here and get a plus, a so-called add operator. You don't need to swap the input. This is perfectly fine already, but you want to make sure that you get the X, so you want to add this one on top. And just right click and straighten connection. This is basically it. And then the result is our index. Boom, compile and save. Pretty simple stuff. So we can close this function. Back here, you can now drag and drop the get index from X and Y and connect this to the branch. So it can fit It's inside our bounds. Yes, we get now the index of our inventory. And you get the absolute here, the absolute X. Okay, the result, you can see here. Put this into the X and then make it more obvious here. Like so. And for Y, just put this inside here. And do it like so. That's it. Let me put this one here. Now, one last thing. We need to get our grid cells. Drag off of here and get a copy. Not a wrap, a copy. And then get the index of our function. And then right click here and promote to a variable. And we call this variable, you can see here on the left, you can rename this one the cell GUID. And connect this one. And now we want to make sure that we drag off of here and we get an equal. Just type an equal, a simple equal operator here. And we want to compare this first with our empty GUID. So just get a make GUID and put this into the second equal operator here, like so. And you can drag select this one. So when we check this, we can see, or we can check if this is empty or not. Once we want to add or switch our item inside our inventory, we can always check, or we need to check if this is empty or not. Otherwise, it's not gonna work. And then just drag off of here, get another equal node, or just copy the existing one. Doesn't really matter. And what we want to compare here from our grid, from our inventory grid, we want to compare this one if we already have an instance ID. So let's just drag from here. I will show you. Just go back to the can place item add. This is your function, the function input. Ignore instance ID. Just drag off of here all the way, or just right click and promote to variable. This is up to you. And put this into the second equal check. And then clean this one up. Just double click here and get another one. Double click here and put this down. And then let's just drag, shift and drag, and press Q. Okay. And drag select, press C, and we call this one is ignored item. Now we get an OR boolean. Just right click and OR a bool. Just a simple OR a boolean. And whether if it's empty or it's an ignored item, once we switch or once we add our item to our grid, we can then say here, drag off of here, then decide whether if it's true or false with a branch, continue this loop, check here. And if this is false, just right click and get a return node. False, put this one inside here. And the true, you can just leave for now. We don't need a connection for the true, because when you go back here to the event graph, you can now get your can place, okay? And once our count, in this case of 50 slots here, remember, once it's completed, we can check whether we can put this item inside our inventory or not. And that's basically it. Compile and save. So we can make a check. You remember that we added a green herb and the pistol, right? So when I open up the data table here, this row name, this is pretty important. This is pretty important. We have the green herb here without a spacebar, and we have the pistol. So we need to look at this name. This is pretty important. This is our row name. It needs to be exactly the same. So for example, we can check the green herb. Just type it in, compile and save. And then we can get a print string. So whether it's gonna find or not. And then let's connect also the can place. And once you right click here on the top left position, right click, split struct pin. So once we add our inventory later, I mean, we don't have any pickup function, we don't have any inventory thumbnails, we don't have any items yet, but this is just for us to understand whether we can place our items right away or not once we press play. This is just a check. So on our top left position, X and Y, we can see this would be our very first cell size, and then he's counting from top left to right and then down, then from left to right and down, left to right, down, left to right. So this is how he counts. So we should not have any trouble to add items on our very first slot. And the green herb, you can see inside our data table. Here, the green herb has one slot on the X. Okay, so from left to right is just one occupied cell, but it's gonna go down, so it's a vertical, so we have 2 slots in total occupied. And this means we can now check this one. So if I compile and save, we can actually test this with our character, so in this case our green herb. But before we can test this, you need to go to your third person, whatever kind of character you have. So for our third person template, I'm just going to go to third person blueprints, open up the default character, which is currently active. So the BP third person character. And here we need to add the BP inventory. This is our actor component. And this is what you can add to any type of character. So the BP inventory. This is all the logic inside here. So compile and save. And once this actor component is being added or attached to our character, this will always fire simultaneously. This will always play automatically. So we should now try this one out. And this works pretty nice because we have a true. So don't mind the ugly graphic here, but when you press play, you can see that this one is true. So this means he's gonna find the item. He also has enough space. So for example, if I put this to, let's say, let me put this to 9. So we have the width to 10 cells. So let me put this to 9, which would be fine for us. But let me put this to something like 5, for example, because our height is only 5. So but when we put this to 9 and 5, it will already be out of bounds because our green herb in this case is built, the shape is built like this. X, just one cell, but then for the Y, it goes down 1. So we would already be out of bounds. We would already be at the position Y at 6, which is not possible. So he should spit out now the false for our print. So this is out of bounds. And we can see it's false. So this is gonna work. So if I try, let's say 4 and 3 for X and Y, this would be still inbound. Okay, so this would be like anywhere inside our grid. So 4 and 3, we can just compile and save and check if this is true. And this one is true. Okay. And if we put this, for example, to 9, let me put this to 9 and 3. And you can see it's true. So because we have for the width, for the X, we have 10. If I put this to 10, it should be false. Yes, it should be false. So don't be confused, because if you think like, hey, it's 10, but our width is 10, this is because he's counting from 0 to 9. This would be 10. This is the reason. It's always a little confusing, but 10 is actually, like, technically it's already out of bounds, because he's always counting from 0 and not from 1. This is just something you have to keep in mind, as it is for integer variables. Okay, so if I put this to -1 and 0, just another example, it should not work. It should be false. And you can see it's false. Now let's check 0 and 0. So this is our starting position. This is always gonna work. Let's check if we have a different name. Let's set this one back to none. So it should be false, because he cannot find this item name. And it's false. Pistol. So this is what we did also here inside our data table. The pistol, the exact same row name you need to have here. Let me close down the character here. So the pistol should also work. And the pistol has, sorry, this is the pistol. And the pistol has a 4 and 4 dimensions. Which is wrong, sorry for that. It's 2 and 2, sorry, my mistake. Sorry for that. It's 2 and 2 on X and Y. Otherwise, if it's 4 and 4, it would then be, you need to have 8 occupied cells here. This is pretty stupid. So 2 and 2, of course. Sorry for that. So our pistol, the same name here, like we have here. And then we can see if this is true. And it is true. Perfect. Another quick check you should also have. So once this is working for you, you are good to go. So this is what I'm going to do also. I'm always going to print just for you guys to understand if this is correct or not. You can also do a print here, just a little, like just before our inbounds. You can also do a check. If the item shape is being counted correctly. So this is something you can also do. We can get a print here after the loop body. Let's get a print. Let's print the modulo and put this here inside our print. So for the pistol, we should have something like 0101. So this means we have, okay, how can I explain this to you? The pistol in this case has a shape of 2 and 2, X and Y. So it's the perfect square, I told you. 2 and 2. We just changed this because I made a mistake. It's not 4 and 4. This means the first X, so the first row would be 0, and then he's counting from left to right. So 0, and then the next one, X, would be 1. And then he's counting, then he's going down on the Y-axis, and then he's counting again from 0 to 1. So we should have something like 0101. So let's press play. And we have 1010. This is something you should have also. Now what you're going to do, let's disconnect this one by Alt-click here. Okay, and then let's test out the divide. Okay, let's get this one instead. And here you should have a value of 1, 1, and 0, 0. So let's try this one. 1, 1, 0, 0. Okay. And this means that everything is correct. So everything I just showed you here, completely uncut, is exactly what you need to have. Okay. Then I just delete the print here. You can see compile and save. So this is it for now for the first part here. This is already a lot of logic, but we are not done yet. Bear with me. But once we have it, it's going to be much more fun later. And yeah, so this is it for the first part. And in the next part, we're just going to continue.